Right, welcome. Today is Wednesday, March 25th. Here's our old calendar. We're supposed to have a lab test tomorrow. Obviously, that is canceled. However, tomorrow we will have some form of quiz online using Canvas. So make sure you log into Canvas anytime between midnight tonight and midnight tomorrow. The quiz will lock itself at 11:59 p.m. tomorrow. So anytime, we're kind of doing this in our honors class today. They're kind of our guinea pigs, but I think everything is going well, kind of. So it's enough to scale it up to the other classes. So quiz tomorrow on Canvas, on circuits. Be ready. Today we're going to go over some more Req problems. Is it going to be on the second half of Unit 8? Yeah, on circuits. Remember, we took a electrostatics quiz already, which I left at school. I think I have to somehow talk to Hussey and schedule a day where I can go to school and then bring a bunch of stuff back so that I can put stuff in. But until then, we have a quiz tomorrow on Canvas on circuits. Yep. Our numbers are dwindling a little bit, which is frightening. We still have a final to prep for, so don't give up yet. Your grade is going to be slightly more heavily favored towards tests because we have less assignments now. So these big giant final exams are going to matter slightly more. So we want to make sure we are fully prepared for the final exam. All right. So let me move this out of the way. There we go. Oops. Req Practice. Oh, what? Go away. We were looking at basically the second circuits PowerPoint. Which is simplifying circuits. It looks slightly different because I was playing around with the design today, but yours should be just blank and no design, just white with black text. But it's the same one. It's a second circuit PowerPoint. Right. Our goal is to do this. I guess maybe we should do it one by one. Let's go ahead and class flow it up. Do we know our class flow code? QGX7X. So let me log into class flow. Class flow. And we'll do it one at a time. Starting with the first set. And then we'll take a quiz tomorrow. No stream tomorrow, but just a quiz. And then on Friday, we'll go over the tippers and the AP review stuff. Let's see. Okay. So here we are. We'll do it one at a time. So this is, let's go and do just number one. Here we go. Figure one, we're doing figure one right now on ClassFlow. And what you want to do is type the Req equation. Type the Req equation based on which resistors are in series with each other and which ones are parallel with each other. If they're in series, of course, the total resistance, or R equivalent Req, is just the sum of the resistors, right? And if they are parallel, well, we can use the parallel symbol. Actually, let's go and do the first one together. Maybe it will make a little bit more sense. So on the first one, we had resistor 1 followed by resistor 2, and then resistor 3 looks like it's attached to it, like so. Okay. And we're supposed to, what are we supposed to do? We're supposed to find which ones are series, which are parallel. So we want to write down the Req equation, basically. The Req equation will tell us. Of course, if you do the current flow diagram, the current comes in. It doesn't matter which direction. But as soon as you hit this first junction, it can go through resistor 2 or resistor 3, and then it recombines again. Like so. Yeah. And so what I would write is that the 2 and 3 are parallel, and then after they are combined, they are in series with R1. So R2, 3 would be the parallel combination. So this would be R1, oops, let me change, R1 plus the parallel of 2 and 3. R2 parallel R3. Alright. Okay, so on class though, you should have written, oh, we got some answers. Let's take a look. We have, it's glitching out. I can't zoom in. I have to actually click on it. No, I can't. R1 plus R, oh, you did the actual combination rule. Very good. Product over sum, product over sum. We also have 1 over R1. Careful with the 1 over rule. So one of you did the 1 over 1 over. The 1 over 1 over, remember, is 1 over 1 over, meaning there's a 1 in the numerator, and then it's the reciprocals. Oops. Okay, so it's the reciprocal of reciprocals added together. Okay, so you would write 1 slash parentheses 1 slash R2 plus 1 slash R3 close parentheses, and then plus R1. So if you did the 1 over 1 over, make sure you have reciprocal of reciprocals added together. Well, 3 responses. That's all right. We'll skip the first one. Now for actual question, let's go and do number 2. In number 2, okay, we have this. Let's see if I can zoom in. There we go. All right, how is this different? Well, if you follow the current flow diagram, the current goes straight into our junction. Okay, it splits off between R1 and R2. Whatever goes through R1 goes through R2. And whatever's left over must be going through R3. And so after it splits, it combines again, and this is what tells you that these 2 branches are parallel to each other. Okay, We got Josue and Owen leading the charge. But we only have 5 connections, but a bunch of lurkers in the stream who are not participating. So make sure you participate if you're in the stream. Scum Shop, Virgo, User 12, Fast Butter, Kreia, Commander Root. Yeah. So we're getting some more now. Very cool. Very cool. We got Shiraz, Megan, Emma. So again, always draw the current flow diagram. Look at the current. I am participating. Come on, Fast Butter. Who are you, Fast Butter? I don't know who you are. That's probably why. Is it Megan? Are you Megan? Oh, you're Josue. Okay. Fast Butter. Cool. Yeah, very good. We have R1 plus R2 times R3 over R1 plus R2 plus R3. Interesting. So we've simplified it. Very good. We have R1 plus R2 parallel to R3. Cool. So the easy way would be to write it like so. So the second one, we had R1 in series with R2, and then the branch of R3 is parallel to it, so R1 plus R2 parallel to R3. Alright, PowerPoint numero 3. Number 3. Numéro 3. There we go. Now we're coming at a diagonal here, but doesn't matter. Just focus on the current flow diagram. Imagine current coming into a junction. What does it do when it hits a corner? Text. Oh no, whoops. Let's try that again. There we go. Alright, so it comes into a corner. Flow, flow, flow. Some of it might go through R1, some of it might go through R2, 3. This is a little too easy. I'm only going to give you a few seconds for this one. Treat it like it's science bowl this way. You got to get it right and get it fast. Ooh. All right, and 5, 4, 3, 2. We have Josue, Megan, Emma, Owen, and Shiraz. Okay. Now, Shiraz, although you may be right, your model, your answer doesn't actually state what is R23, right? Imagine science. So please refrain from spamming. So it doesn't technically state what is happening to 2 and 3. So you want to be as clear as possible on what you're trying to say using this notation. So in figure 3, we see that R1 is by itself. R1 is by itself, and it's in parallel to the combination of 2 and 3. But 2 and 3 are series because there's only one pathway. Why do I still get bullied online? Huh? Oh, well, it's Science Bowl. Didn't you guys have your competition? Isn't it like once a year anyway? So Science Bowl is technically over. Imagine being in robotics where this entire season got canceled. Ooh, ouch. All right. let's try number 4. Hopefully this stuff picks up. Now the first slide is kind of easy. It'll get slightly harder on the second slide, I promise. Is there anything that isn't canceled? Physics. Physics is not canceled. We're going to keep going because we're going to save the world. There you go. Physics can never be canceled. Let's go and try figure 4 now. Okay, pretty easy, pretty easy. Just some head scratchers to start the morning. And you'll see that there's a slight difference between 4 and 5. We'll get to 5 in a second, but let's focus on the 4 first. Okay, imagine current flowing. Some of it's going left, some of it's going right. And of course, we can use the current split rule, to figure out how much current actually goes through each branch. And if you missed all the notes and stuff for like Kirchhoff's branches and notes, the rest of this PowerPoint has some cool information. So you can take a look at the PowerPoint and all that. Oops, what am I doing? Here we go. We're back. Yeah. All right, we got our participants. We have 7 people online now on ClassFlow. Very good. We added Hail, hey, Hail Chiba. Welcome, welcome. All right, so let's go and stop it. Very good. So as you can see, 1 and 2 are in series, 3 and 4 are in series, and then those 2 branches are parallel to each other. Owen, what? 1 plus 2 over 3 plus 4 over 1. Oh, I see. Owen did the product over sum for both branches. Very good, Owen. So the simplified model would be 1 plus 2 in parallel with 3 and 4. Okay, and of course we have to understand that whenever you have 2 resistors like R12 and R34, you can do product over sum for those 2 resistors. All right, number 5. Now how is number 5 different? It's this little tiny wire in the middle that changes everything. So let's take a look at number 5. So similar to 4, but there's this wire here that changes everything. Okay. So if you can basically circle any region in your circuit without any circuit element, you can call that region a node. And so what can you do with a node? Well, you can squish it down into a point. So let me demonstrate. We have 1, 2, and then there's this line here, and then 3, 4. Okay, so again, to identify nodes, what you want to do is circle or find spots or regions where there are no circuit elements. So I have that one. Here's a region where there are no circuit elements. So a circuit element could be any resistor, diode, LED, inductor, capacitor, all these other fancy stuff that you can put in. Let's use let's use red. No, let's use blue. No, let's use purple. No, I like blue. Okay, that one. All right. So these 3 things, we can call them nodes. So these are nodes. Okay. And so when you see a node, you can just squish them into a point. So use your pincer-like grip and squeeze the ends of the wires here, and use the force to push them in so that it squishes down and ends up looking like this. Here's our orange one. So here's our orange node, and from the orange node we have two resistors, R1, R3. And then let's go and squish and squeeze the pink one. So now it's just a dot. And from that dot we have R2, R4. And finally, let's go and squish the blue one into a dot, into a point. And voila, we've redrawn our circuit. So basically these two are the same. And so if we do a current flow diagram, the current can come in and then it'll split off between 2 and 3, but then recombine. So if it splits and recombines, that means 2 and 3 are parallel. And then it splits off again between 2 and 4, and then recombines, therefore 2 and 4 are also parallel. Alright. So we're getting some answers. We have Josh H. Joshua Huang has joined. Very good, Josh. Welcome. I'm guessing you guys are staying up late and you can't wake up early anymore. That is not good. You've destroyed your sleep schedule. Mine is getting close. I've been sleeping later and later because I can't fall asleep, which makes it harder and harder to wake up. However, I don't have to wake up at 4 a.m. anymore, so that's good. Joshua Huang is in chat now. Hale, Shiraz, Josh, Owen, Emma, Husway, Megan. Did we lose someone? Stovetop. Aren't you Aiden Garospi? Where's Aiden Garospi? Yeah, I love physics. You're not on ClassFlow. Get on ClassFlow. We are on ClassFlow. All right. Looks like we're pretty much done. Yes, they're parallel, and then once you combine the two parallels, it becomes in series. So for figure 5, we have R1 parallel to R3, which is in series with R2 parallel with R4. All right, let's finish up this easy first slide with the last one, and then we'll do something slightly more complicated on the next slide. What's the code? Yes. I should add one of those. How do you add one of those like those chat things where you can do like exclamation point code and then it gives you the code? What are those things called? Well, I have a bot. It's called CloudBot, but I don't know what they're called. Quotes? Maybe it's a quote. No, it's not a quote. Timers. Commands. Maybe they're called commands. Yes, it is a command. Add command. Command is exclamation mark code. Response is QBX. Reply in chat, permission by everyone. Confirm it is added. Can someone test it out? Type in factorial. Exclamation mark code. See if it works. Hey, it works. We did it. Yeah, it even works with caps. Very cool. All right. All right, let's go and finish it off. Number 6, and then we'll move on to the second slide. I can take some Q&A things if you have, especially from Mastering Physics. Remember, you have Mastering Physics Chapter 22 and 23. 22 is up due pretty soon. 23, I believe, is like early next week. I can't remember the dates. Check your Mastering Physics calendar for the dates. Oops, this is not Figure 2. It's Figure 6. There we go. Text. Go ahead and enter Figure 6. Let's see if we can do this. It's very similar to one we have already done. What was the answer to 5? My stream lagged. The answer to 5. Here we go. We actually talked about a bunch of stuff. We redrew the circuit, so it looks like this. What we found out is that all these nodes, you can squish them down into a point, so the circuit ends up looking like this. And so 1 and 3 are parallel, 2 and 4 are parallel, and then they are in series with each other. You can even do like the weird caps, capital, lowercase, capital, lowercase. What is that called? That's like a SpongeBob meme or something. The dummy SpongeBob meme. And the bot recognizes it. Alright, so number 6 now. Number 6. Pretty simple. Notice how it's basically like in reverse of the first one. Do we have our answers? Emma, Megan, Owen, Josue, and Josh. Got it. 3 responses remaining. Yeah. And Hale's on the board. All right. So done with the easy stuff. Oh, Shiraz just made it at the buzzer. Good. So 1 and 2 are in series and then in parallel with 3. 6. 1 and 2 in series. So parallel with 3. Alright, juggling 3 conferences, right? What everyone's doing their conferences at 10 o'clock. It's prime time. It is prime time. Who are the other teachers? I mean, Dalsa said he would do his like in the afternoon. So did Webster. Webster said he'll do it later during the day. So who do I need to talk to? There's a chem conference, of course. Solaris. Oh, the history teachers. Yeah. Yeah, this is destroying our viewership. His conference was yesterday, though. Whose conference? Solaris' conference? The A push teacher? Well, it is what it is. We could always watch our VODs, I suppose, but it's not as fun. Alright, moving on to actual calculations. Get your calculators out. The first couple are pretty easy, but there are some tricky ones, so stay tuned for some tricky ones. Here's number 1. The directions are find Req from A to B. So let me write that down. The overall directions are find Req from A to B. Okay, so sometimes you can kind of write it as RAB or something like this. This will tell you that the current is coming into junction A and then going out of junction B. So you would do a current flow diagram from A to B and then figure out what the Req is. So this is figure number 1-2. No, I should say 2-1. There we go. So figure slide 2, number 1. And we're looking for an actual numerical answer this time, a numerical answer. It says all resistors are 500 ohms, and you want to find a Req. And use patterns. Technically, you don't need a calculator for this one. Use patterns. Then looking for patterns will save you a bunch of time. Okay. So imagine current coming into junction A. So what does that mean? Well, if you were to redraw this, you would say that you have current coming into junction A, and the current leaves junction B. So the flow would be this way and out. All right. And use patterns. If you look for patterns, this will save so much time. All right. Of course, you can add 500 and 500. But remember, Req for 2, especially not just the product over sum part, but Req for 2 when the resistors are the same. Right? Ooh, Josh with the actual omega symbol. Very good, Josh. Wireless high five for Josh. We're trying to look for a wireless high five emote. Now that we are an affiliate of Twitch, we can actually have our personalized emotes and emojis. So if you have an idea for a wireless high five emote, please email it to me, and then I'll get that going, and then we can use a wireless high five emote in chat. So let's give a wireless high five emote to Joshua for using the omega symbol. All right, yeah. So this one's pretty much done with. We can see that we have 2 in series with each other. The other 2 are in series. So the 500 and 500 make 1,000. So that means we have 1,000 ohm this way. And then another 1,000 ohms this way. And when you have Req for 2 and they're both the same, the Req gives you half of one of them, right? 1,000 times 1,000 over 1,000 plus 1,000 gives you 500. Okay. Things to note. Okay, of course, when they're the same, you get half of it. But what if they're not the same? Like 1,777 or something. Okay? Of course, you can do the product over sum still, but things to note is that no matter what values you get when you're in parallel, Req is always less than the lowest resistor. Okay, so in this case, Req has to be less than 777. Okay, can we verify? Let's go and verify. 1,000 times 777 divided by 1,000 plus 777 is equal to, can we get a value? Ooh, Stovetop already has it down. Is that Aiden Garospi? Who is Stovetop? Oh, it's Santiago. Oh my gosh. Haha. It's Hopkins. Very cool. Wait, I thought we had Aiden Garospi the other day. I don't know which one it is. Alright, anyway. So the value will always be less than either of the 2. That's because by opening up a new pathway, you're going to get more current flowing through your system. Even if the other one, 8 and, very good. Even if you have more resistance in the other pathway, you're still getting more flow. Therefore, the overall resistance, Req, is going to be less. All right. Cool. Everyone got the first one. Let's go and move on to the second one here, figure 2. Ooh, this one's slightly different now. B is now, somewhere on the side here. Use the same strategy. What did I just do? I drew some arrows indicating where the current's coming in and which way the current's flowing out. That's how it helped me determine which ones are in series and which ones are in parallel. It says Slazer is now following you on Twitch. Wait, why didn't our alert box work? That was weird. Alert box, why you no work? Typically when you hit the follow button it does a little giraffe gif and it shows you who follows. Or maybe it's delayed. Shiraz, did you just follow now? That doesn't look right. Yeah, so apparently I just, like, at 10 o'clock I got an email says you followed. Thanks, Shiraz. I got a super delayed email. Oh, we got some numbers. We got a fraction. Yikes. Typically when you answer questions with numbers, use numbers. Cool. So we have 3 in series if you use the strategy. We have 1 response remaining. Whoever you are, hurry up and type something in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, you'll get them next time, bud. So we have 3 in series. What did it look like again? Oh yeah. So if B is here, that means it's coming out and it's going in through here. So it'll flow through these 3 and then this one. And it'll go out this way. So that makes 3,000 and 1,000. I should write 1,000. 3,000. And just Req for 2 for 3,000 and 1,000. And notice how it's going to be less than 1,000. So 3,000 times 1,000 over 3,000 plus 1,000 is 750. 750. Wow, 100%. Woo. Alright, these are a little too easy, huh? I am going to skip this one because it looks familiar. Ah, here we go. Let's try some harder ones. Figure 4. Ooh, gotta be careful. Don't want to slip on any banana peels. Are we getting anything? We're not getting anything. People are stuck. Okay. Flow. Hint. Current takes the path of least resistance. Current takes the path of least resistance. Okay. Maybe if I redrew it, it might help. Always try to redraw circuits so that it makes a little bit more sense. So here's our circuit, right? 250, 470, 940. Okay. So it looks like this currently 940 ohms. We have the 470 ohms. Oh, I missed one. And then the 250. And then B. Right? Okay. If I were to redraw it so it looks nice and even and straight, we have A into the first resistor. Okay. And then we have kind of two paths. Either I can go this scenic route or take the shortcut. And if I take the scenic route, I hit two traffic jams. 470 and a 250. And then we're out through B. Okay. What do we call this shortcut that has no resistance in its path? Because when the current comes into this junction, it has a choice. Should I take the path of zero resistance or a bunch of resistance? Okay, a short circuit. Yes, we have short-circuited the 250 and the 470. So if you short-circuit it, that means these two resistors will receive zero current. In effect, we've reduced it down to just a single resistor. Okay, when you have a short circuit, 100% of your current goes through the short circuit and nothing goes through the other ones. All right. So what is the answer? The answer is 940. 940. All right. Okay. That one's kind of easy. All right. Let's go to an even harder one. Number 6. Okay, our goal is to use the strategy, basically, draw the current flow diagram, and then redraw the circuit. Okay, find which ones are parallel, which ones are series, simplify it, and this will help immensely. The current is coming into junction A, and then it splits up, and then it comes out of junction B. Identify your nodes. If you can find nodes, squish them into a point. All right. Let me go and redraw it. So we have the 220, the 100, the 470s in the middle. Okay, followed by a 330 hanging on the left side here. Okay, and then we have B. Okay. Identify nodes. So can you circle a region where there are no circuit elements. Okay, I see one good one. This entire region here. And then I'm going to use the force and squish it into a point. So squeeze this, the squeeze theorem of circuits. It's kind of like the squeeze theorem of calculus. And let's go and squish another one. Let's use orange here. How about this region here? Let's go and squish this into a dot and redraw our circuit. So we have A. Oops. There we go. This is still the 220. Okay, and then we have the 100. Okay, now we do have this thing here, the 470. We also have a 330 here. We're supposed to squish this into a point, so that means these two are connected. So let's go and draw it this way now. All right. So what does that mean? If I look at it sideways, now look at it sideways, we have the 330, the 470, okay, and then we have the 220 up here. And the 100 here. Okay, where's the current coming in? It's from junction A. So that's junction A. And where's it going out? Well, it's going out at the bottom of these two. Okay, this means that the 330 and the 470 are parallel. So these two are parallel, and we can redraw it one more time. So we have this new resistor, which is the parallel of 330 and 470. Let's quickly do that. So that's 330 times 470 divided by 330 plus 470. 700 plus 100 is 800. And so 193.875, so 194-ish. Okay. Product over sum. Okay. And then we have, our thingy is working. Thanks for following. Then we have the 220. All right. Then we have, again, we're coming out from here. Then we have the 100. And we're going into junction A. Now it's looking more and more like the things that we've done. Okay. Once it's parallel, the 194 and the 220 are in series, which is in parallel with the 100. So Req equals 194 plus the 220 in parallel with 100. I should definitely use units. I don't know. I'm kind of being lazy today. Let's go and use units. Omega. I want to be like Josh because he's doing it right. Okay. And so 194 plus, I'm going to keep the original values, plus 220 gives us the 414 or 413.875. And then we'll just go ahead and do a product over sum. So times 100 divided by 500 and whatever. I used the original number, so I kept the actual values. So I get 80 and a half. Ooh, we got a few people. Yeah, if you use the rounded version, of course it'll be close to 80. If you're close to 80, you are good to go. Oh, whoops! I was supposed to turn off names. Sorry. This is supposed to be a work conducive environment, not a hostile work environment. I will make sure to turn off names next time. All right, so that is all. That is all. Thanks for tuning in. Make sure you do your. Where are your units this way? Yeah, this way. Omega ohms. Make sure you do your mastering physics. We will take a. There's no stream tomorrow. We'll take a quiz tomorrow. A small quiz on Canvas. So log into Canvas anytime before midnight tomorrow to take your quiz, and then on Friday we'll go over the tippers and all that other stuff. All right. So thanks for tuning in. Make sure you follow or subscribe to our YouTube channel. I'll see you next time.